Let's talk a little bit about systems of equations, and we're going to break that down super easy, breezy, beautiful systems of equations. So let's say you get a question like this. Now, this is going to be a system with a line and a system with a parabola, which means we have a linear and quadratic system. Let's take a look at what that looks like. Big picture, if we take the parabola, it's going to look something like that. And there's going to be a line that either intersects like this. Maybe it goes underneath, right? And it doesn't intersect at all. Maybe the line intersects at exactly 1 point and it like hits just 1 point right there. And this could be in any arrangement. It's kind of like solutions for a quadratic, except I could have my line here, or I could have my line right there where it only touches at 1 point. Instead of the line for solutions being the x-axis, now it's whatever line that they give you, and our solutions are where those two things intersect. Pretty much, if it says that it intersects a parabola at exactly 1 point, if the parabola has equation y equals negative 4x squared plus bx, where b is a positive constant, what is the value of b? The fastest and most straightforward approach to this is going to be using Desmos if we're lucky. So we could say 2y equals 4.5. That's going to give me a line. Then I could say y equals negative 4x squared plus bx. Now here's a problem. We don't know what b is. So Desmos, if we use that, it's just going to give us the option of using a slider. Now we could simply maneuver this slider to the point where there's one solution, exactly one solution. So I might want to zoom in for this. It's an imprecise way to do it, but it is a way to do it nonetheless. Sometimes the SAT is nice and they'll do something where like it looks like it's about 6, and then boom, my one solution is right there. And they're asking what's the value of b, so b would be 6 in this case. Now, sometimes it's a little bit more difficult because you can't just get to something by just using Desmos and approximating and just moving. Maybe it's like too close and you end up getting something like 6.739 and it's got to be something super exact. You end up wasting more time on Desmos than just doing it manually. How do we do that manually? Well, what we do is we take our two equations. I have my 2y equals 4.5. My y equals negative 4x squared plus bx. I know that I'm looking for my b when it intersects at exactly 1 point. So at this, we would need knowledge about our discriminant. We'll go over in a second, and how to set these two equations equal to each other. First things first, I want this y term to either be this to be 2y or this to be y by itself. So let's go ahead and get this y by itself. Divided by 2, y equals 4.5 divided by 2. I like to get it into fraction form, 9 over 4. Now that 9 over 4, that y can go over here, so I can have 9 over 4 equal to negative 4x squared plus bx. And I know I want this to be equal to 0, so I have it into standard form. Let's go ahead and get this into standard form. Subtract 9 over 4 from both sides. That's going to give me 0 equals negative 4x squared plus bx minus 9 over 4. Now my discriminant is b squared minus 4ac. And since they told me that it was intersects at exactly 1 point, it must mean that my discriminant is equal to 0. Now I plug all these components back in. I say I have nothing for b squared minus 4 times negative 4 minus 9 over 4. And that's going to equal 0. I have b squared, these two cancel out. That's going to be b squared minus 36 equals 0. I'm going to add 36 to both sides. It's going to be b squared equals 36, square root both sides, and then b equals 6. Both ways are going to work. If you have something that is like a fraction, you can look at your answer choices too. If all the answer choices are really just like fractions, then you may have to approximate, or you could use this method to get the exact answer for either my a, b, or c terms, whatever is missing. That's typically how we solve linear and quadratic systems of equations.